Good afternoon, everybody. My name is Valerie Smith. I'm president of Swarthmore College, and I am delighted to welcome you to the annual McCabe Lecture, a highlight of Garnet Weekend. Thank you all so much for being here, both those of you who are here in LPAC as well as those who are tuning in to our live stream. I'm pleased to welcome Michael Greenstone from the class of 1991 back to campus to speak to us about the difficulties and the opportunities posed by the Global Energy Challenge, which happens to be the title of his lecture. In a few moments, two of our McCabe scholars will formally introduce Michael Greenstone. So my job today is to tell you about Thomas B. McCabe, the person for whom this lecture is named. Thomas B. McCabe, a graduate of Swarthmore's class of 1915, was chairman and CEO of Scott Paper Company, chairman of the Board of Governors of the Federal Reserve System, and public governor of the New York Stock Exchange. Mr. McCabe believed deeply in the value of education, and he was widely honored for his contributions to the field. During his lifetime, he received honorary doctoral degrees from 15 colleges and universities, including Swarthmore. President Harry S. Truman awarded him the Medal of Merit for his contributions to education, business, and government. Here at Swarthmore, McCabe's name, vision, foresight, and generosity endure. Generations of students have studied in the Thomas B. and Jeanette L. McCabe Library, and our students have started and ended their Swarthmore experiences in the Scott Amphitheater, a gift from Mr. McCabe. The inaugural McCabe Lecture, established in Thomas McCabe's honor, was held in 1986. Since then, the lecture has reflected his commitment to education and his belief in young people's potential to make their mark in the world. To that end, he also established the McCabe Achievement Awards Scholarship Fund in 1952, which has awarded scholarships to more than 300 Swarthmore students since then, many of whom are here today. Two of them, Hussein Zaidi and Tolu Banjo, are co-presidents of this year's McCabe Scholars. Hussein Zaidi is a senior from Lahore, Pakistan, who is double majoring in health, religion, and society, and biochemistry. Hussein has served as president of the Swarthmore Queer Union, Swarthmore Health Society, and Global Health Forum. He has been actively involved in research initiatives across the globe, ranging from the bioethics of HIV disclosure in South Africa to the effects of healthcare decentralization in Tajikistan. He has co-authored over 7 manuscripts as an undergraduate on topics in healthcare policy and management, and he is also involved in leading LGBTQ+ activism efforts in his home country, where he co-founded Pachan, Pakistan's first youth-led LGBTQ+ rights advocacy organization. Tolu Banjo is a senior majoring in medical anthropology and minoring in chemistry. Tolu is passionate about medicine, promoting holistic well-being, and making medicine accessible to marginalized communities. Tolu is a Black Cultural Center student intern and a former co-president of Swarthmore African Student Association. Her interest in medicine has been solidified in her work as a research intern with the chemistry department and as a student researcher at the Nemours Children's Hospital in their orthopedic surgery division. On campus, you will most likely find Tolu in the Science Center doing chemistry research in the Riley Lab or working as a teaching assistant in chemistry classes. In her free time, Tolu likes to dance, spend time with family and friends, and watch movies. Please join me in welcoming Tolu and Hussein to the stage.
Good afternoon, and thank you, President Smith. Welcome, everyone physically and virtually present, to this year's Thomas B. McCabe Lecture. It is our pleasure to introduce this year's speaker, Michael Greenstone, class of 1991. Michael Greenstone is the Milton Friedman Distinguished Service Professor in Economics, as well as Director of the Becker-Friedman Institute and the Interdisciplinary Energy Policy Institute at the University of Chicago. He previously served as the chief economist for President Barack Obama's Council of Economic Advisors, where he co-led the development of the US government's social cost of carbon. He is an elected member of the American Academy of Arts and Sciences, a fellow of the Econometric Society, a Carnegie Fellow, and a former editor of the Journal of Political Economy. Previously, Greenstone was the 3M Professor of Environmental Economics at the Massachusetts Institute of Technology and Director of the Hamilton Project.
Greenstone's research, which has influenced policy globally, is focused on uncovering the benefits and costs of environmental quality in society's energy choices. His current work involves testing innovative ways to increase energy access and improve the efficiency of environmental regulations globally. As a co-director of the Climate Impact Lab, he produces empirically grounded estimates of the local and global impacts of climate change. He also created the Air Quality Life Index, which demonstrates the impact of air pollution concentration of life expectancy, and co-founded the Climate Vault, a nonprofit that uses markets to allow people and institutions to reduce their carbon footprint. Greenstone received a PhD in economics from Princeton University and a BA in economics with high honors from Swarthmore College. Please welcome in welcoming Michael Greenstone.
Thank you for that very kind and generous introduction. I want to begin by just highlighting that what was now, I guess, 30 years ago, I was a student here, and there were always the McCabe Scholars, and it was as if we had been admitted to kind of like the junior college, and the McCabe Scholars were in the real college. They were always so impressive, and it's an honor to be here and talking to them and talking to past ones and current ones. So I'm going to talk about what I like to call the global energy challenge, and I think it's I will try to be a little provocative about it and say that when you think about the climate challenge, you're actually making a mistake. You should think about the global energy challenge, and let me try and describe why I've reached that conclusion. So this is a friend of mine, Nancy Chen. I was asking her once for a picture of China, and I was describing, I was describing some of my work, and she said, "Oh, I know just the picture that captures that." And so I think this picture really captures the global energy challenge, and I think of it as the defining challenge that our generation and maybe the next generation are going to have to confront. And this is a picture from Beijing. It's probably 6 or 7 years ago. And I can think of the global energy challenge as kind of a stool that has 3 legs. And I think it captures all 3 very well. So the first is you can just feel viscerally, and if you've been to China, you'll recognize it, that like China is a country on the make. 30 years ago, the improvement in per capita incomes in the last 30 years, I think it's almost without historical precedent, pulling 900 million people, or maybe it's 1 billion people now, out of extreme poverty. And a lot of that was powered by access to inexpensive and reliable energy. And you can see it. The guy in the car, or the cab there, he was probably on a bike 10 years ago. And the guy in the bike, he's going to be in a car in the blink of an eye. And all these advances in living standards that we take for granted here, were made possible by access to inexpensive and reliable energy. And so I think of that as the first leg of the stool that all societies around the world have to confront. How are we going to get access to inexpensive and reliable sources of energy that are so critical for living standards? The second leg of the stool is that the same massive increase in energy that has unlocked these advances in living standards, in the case of this picture, came bundled with horrific air pollution. And this horrific air pollution is not a secret to the guy on the bike. He's got on goggles, he has on gloves, you can almost see them. And it's the middle of the day in Beijing and you can't see the sun. And so the second leg of the stool is, well, I'm gonna need all this energy. A lot of this is coming from fossil fuels. The fossil fuels involve the release of these terrible particulates, air pollution. How am I gonna try and manage that? And the third leg of the stool is the same fossil fuels that are causing air pollution and that have unlocked the income growth are also leading, you can't see it, but you know it's there, leading to disruptive climate change. And so what I want you to think about is not think about, well, how can I narrowly solve climate change, but how can I as a society, be it a society in Swarthmore, Pennsylvania, or a society in Beijing, or a society in Mumbai, find a way to balance between those three goals. And that's like the fundamental tension, I think, of the global energy challenge. It's not hard to think of ways to hit one of those goals or two of those goals, but if you want to get all three, there's going to have to be trade-offs. And what I'll keep trying to come back to is that those trade-offs look very different depending on where you are in the world. And what I mean by where you are, I mean how wealthy your society is, what the current climate is like, values, morals, a whole series of things. And in one way or another, we're all dependent on there being an answer that where we don't make it very hard for everyone else and they don't make it very hard for us. So let me try and dive into it. Now, I don't know if it's going to work in this kind of room, but I should have just said from the outset, if you have a question, I will save time at the end, but it'll work even better if you ask a question in the middle. And so maybe we'll task President Smith with asking the first question just to facilitate people asking questions. It doesn't have to be at this moment, but whenever she feels so moved. Okay, so I'm going to try and illustrate this global energy challenge begin with 7 facts. And that, the tension here is going to be to explain the difficult balance between energy and growth. So the first is that energy is critical for growth. Again, I'm not sure this is going to be the right room. It usually works in a smaller room, but I will try it here to tell a joke about this graph. So I spend most of my day analyzing data. Data is so disappointing. It always finds some new way to contradict your hypothesis. But what's remarkable about this graph is that it so tightly fits the hypothesis. And here the hypothesis is that energy is critical for growth. And so I just want you to take as kind of a fixed fact, if we're going to have high levels of living standards, which are marked on the vertical axis, we don't have a historical example of any society achieving that without consuming lots and lots of energy. So that's fact 1. Fact 2 is coming. Oh, there we go. Okay, so fact 2 is that energy access is a major problem around the planet. And I will try to illustrate that here with this figure. And what this figure shows is per capita electricity consumption in the United States, China, all of India, and Bihar. And I'll come to them one by one. So in the United States, the average person uses about 13,000 kilowatt hours of electricity per year. There's about, the number up there is 330 million people in the US. In China, that number is maybe 4,000 or 5,000. There's 1.4 billion. In India, it's about 1,000. And there's 1.4 billion people there. And I do a lot of work in the state of Bihar, India, which is a state that has about 120 million people. People there are living with 200 kilowatt hours per person. Okay, so just stop and think about that. What is, I love numbers, but what's embedded in the 200 kilowatt hours per person? That's all kinds of misery and deprivation. That's there's no cooling, there's no heating. It's backbreaking work, not using machines to do things that we take for granted. And so that's a totally unacceptable state of affairs if you live in Bihar, India. If you live in the rest of India, 1,000 kilowatt hours per year is not really an acceptable state of affairs. So energy access is a major problem around the world. And in fact, energy disparities are larger than even income disparities. Just you can, by comparing the United States and India, you can see that. So, and it's not just that there's not lots of access. So this is rural areas in Nigeria, Ethiopia, Uganda, and India. And this is the number of hours of electricity that people have access to. You can see the highest bar is 0. Most of the people in rural parts of those countries get 0 hours. But even the people who are connected to the grid, they don't have anything like what you're used to. A very small fraction have 24 hours a day. So I'm going to keep coming back to this. Every society is going to have to make these trade-offs themselves, and I just want you to get in the mindset of like, if you're not in Swarthmore, Pennsylvania, but if you're in some other part of the world and you're trying to find a way to balance between those 3 goals, it's going to be very hard to think about something that isn't the first goal, which is access to inexpensive and reliable energy. So, and then the third kind of almost naturally follows from the first 2, which is demand is expected to grow very rapidly in today's emerging economies. This is just up through the present. You can see this is per capita, Canada, the United States. You can see China's remarkable growth here. And if you squint hard enough, you can begin to see India starting to grow. And if you project forward, you can see today's rich countries are basically expected to have relatively flat increases in energy consumption. And there's this very sharp increase going out to the middle of the century projected for today's developing countries. Okay, so that's all fine. Energy is critical for growth. Energy access is a major problem. Demand is not surprisingly expected to grow rapidly in today's developing countries. So none of that would be a problem except for number 4. Number 4 is no matter how much you read about renewables, no matter how much you read about the cool new geothermal project on Swarthmore's campus that I got a very fascinating tour of today, fossil fuels are expected to meet much of this growth. And so it's a little surprising, but if you go to the standard projections, here's from the International Energy Agency. Today, about 80% of all energy comes from fossil fuels. That's coal, oil, and natural gas. In 2040, that's still projected to be 72%. So now how does that fit with everything you've heard about the geothermal plant on the Swarthmore campus, or new solar panels, or wind, offshore wind? Well, the reason is that fossil fuels are incredibly inexpensive when it comes to power production. And so here you can see how much does it cost to produce, the average American is 13,000 kilowatt hours. How much does it cost to produce a kilowatt hour? This data is for the United States. From an existing coal plant, it's about 3 cents. From a natural gas plant, it's about 4 cents per kilowatt hour. That's due to the fracking revolution. From a coal plant with all kinds of environmental controls that are now required in the United States, it's maybe 7 cents. And from a nuclear plant, it's probably 9 cents, although we don't really know because it's so expensive, we don't really build nuclear anymore. So let's start with that. Now, what if you were to actually turn to the zero carbon energy sources? Well, the first thing I'll do is I'll just point out, well, we can't do that by themselves because the sun doesn't shine all the time and the wind doesn't blow all the time, so you're going to have some kind of backup to fill in when they're not performing. When you do that, wind onshore is maybe, let's call that 5.5 cents. Solar is 6 cents, and wind offshore is maybe 9 cents. This is with a natural gas backup. So that's what a lot of the country uses right now when they have renewables. They have natural gas peaker plants that turn on and off very quickly. If you were to instead, and by the way, those are green hats and not just pure green, because of course the natural gas backup is a fossil fuel. If you use a battery backup, the batteries, there's been lots of progress in batteries, but they're still very expensive. And then you can see the costs are even higher. And this is kind of what everyone has to beat. That's the price of natural gas plant in the United States currently. So the reason we're using and are continued to be projected to use so much fossil fuels is that they're cheap. And I'm going to put a little star next to that. They're cheap given the way we've constructed energy markets. And I'm going to just tuck that away. But we've constructed energy markets in a way that they're very cheap, and we're going to come back to why it doesn't have to be that way. It's not just in power and transportation. Fossil fuels are inexpensive as well. So here I built an internal combustion engine car and an electric vehicle, and on the vertical axis we've got the price of oil, which is the primary cost, of lifetime cost of a internal combustion engine car, and on the horizontal axis we've got the cost of a battery. And the red line is combinations of battery prices and oil prices where it's equal cost over the lifetime. And above the red line is where electric vehicles are cheaper, and below it is where internal combustion engines are cheaper. So now we're just going to find a couple points. So if we took today's estimate of the average battery price, it would suggest that oil prices, and so here I'm going to try and make someone talk, that oil prices would have to be $154. So it's totally unfair. I have not prepped this. President Smith, how much is a barrel of oil currently?
I don't have an answer for you.
Does anyone want to help? It's about $80. Okay. So you can see the price of a barrel of oil would have to double before the electric vehicle would actually be cost competitive. And if we instead used, today's price of barrel of oil is $83, then the price of battery would have to come down by maybe 40% or something like that. So we're just not at the point yet where it makes economic sense, if only in a dollars and cents way, for choosing anything but fossil fuels in transport, just like is largely true in power. It's not just that. You know, there was a theory for a while that we were going to run out of fossil fuels. I think there's no good reason to think that that's true. Here's one way to illustrate that. This is in 1980, the ratio of oil reserves to oil production in that year. And in that year, it was about 30-to-1. And so if we had not found any more oil, of course, we would have run out of oil by 2010. But instead, what has happened is now that ratio has gone up to maybe 40-to-50. And how did that happen? That happened because the people who work at the fossil fuel companies, Schlumberger, Exxon, et cetera, are super smart. And they're working hard all the time to get more, find new ways to get access to inexpensive fossil fuels. And so we're not going to run out of that. We're not going to run out of natural gas. And we're surely never going to run out of coal. Okay. So let's just pause where we are. Where we are is fossil fuels are expected to meet much of what is projected to be very large increases in energy. Is that bad? And I'm now going to turn to what are really like the second and the third legs of the stool. The first is fossil fuels increase air pollution. And by that, I don't mean carbon dioxide, but kind of conventional air pollution. And that shortens a lot, causes people to lead shorter and sicker lives in ways that I think are not actually fully appreciated. So about 6 billion people around the world live in areas where particulates concentrations exceed what the WHO says is a safe limit. You can see, I think this is a picture from India, but you can see a lot of them are in Asia. In the chart here, almost all particulates air pollution comes from the combustion of fossil fuels. And then I just couldn't resist, since we're at Swarthmore, well, what do we know about the effects of long-run exposure to air pollution? And so I'm going to borrow from a paper of mine. And this is a paper that examines that question in the context of China. So the idea of the paper is there will never, President Smith and other presidents of colleges and universities are never going to allow researchers to run randomized controlled trials where you subject one set of people to air pollution at a very high concentration for their entire life. and another set at low levels and just kind of measure what happens. So instead, what researchers have to look for are things like natural experiments that mimic a true randomized control trial. And so I stumbled upon this, China's Huai River winter heating policy several years ago, and I think it helps provide some of the conditions that might allow us to make traction on that problem. So let me explain the winter heating policy. It was established during the planning period when China was much less wealthy than it is currently, and they just didn't have enough money to heat every home during the winter. So they did a pretty arbitrary thing. They drew a line across the middle of the country, and they said, if you live north of this line, you get free winter heating. We're going to build you a boiler that'll attach to your building. We're going to give you free coal, and that's going to be true from November 15th to March 15th. But if you live south of the line, you are out of luck. It's not that we're not going to give you free coal, it's that heating is going to be illegal. And so the idea of this paper was, and here's the line, this is the river, which eventually turns into a mountain range. The idea is to compare, and by the way, there was, for much of this period, there was not free migration. So the idea is to compare people born just to the north of the river to people born just to the south. And that might give you some kind of comparison that would allow you to gain traction on what the effects of long-run or lifetime exposure to air pollution is. And so the whole paper boils down to two figures. Oh, here's a picture from China. This is in the north, and you can see it's not like they built giant power generating stations or heat generating stations away from the city center. They put kind of crappy boilers on individual apartment buildings with no environmental controls, and you can see people are living near where the coal is being combusted. So the paper boils down to two figures. The first, so let me describe this. On the horizontal axis, we've got degrees north, latitude, or south, so minus is south, positive is north of the Huai River. Each of the bubbles are 1 degree latitude displacements from the Huai River. So these guys here are people who live 0 to 1 degrees north of the Huai River, and these guys are people who live 0 to 1 degrees south. And the bubbles are just proportional to how many people live in those regions. And this is maybe like the least interesting, but it sets off the paper, is, well, what happens to air pollution at the river's edge? And what you can see is that there's this very sharp increase in air pollution just to the north of the river relative to the south, and such a sharp increase does not exist anywhere else. And China is suggesting that it is really the policy that's causing that. So now there's a companion figure that comes along with this, and that's going to show you life expectancy. And to my eye, this is actually quite shocking result. The people who live just to the south, which are these guys, just to the north rather, are these guys here, and these are the people who live just to the south. The guys to the north live about 3 years less on average than the people who live just to the south. I hope I said that right. In the north, they live about 3 years less right at the river's edge compared to the south. It's all coming from causes of death that are plausibly related to air pollution, cardiorespiratory causes of death. There's no differences in other causes of death. This discrete jump didn't exist before the implementation of the policy. And so it provides like a chance to see, well, what happens when you let people, or when people are exposed to high levels of air pollution for their whole life. So then the paper just takes the two numbers, the 40 micrograms per cubic meter and the 3 years, and uses them to come up with, well, how much does an extra unit of particulates air pollution do to life expectancy? And I took that and I created something called the Air Quality Life Index. And that provides an opportunity for people around the world to see right where they live what air pollution is doing to them. And so here's just a map using satellite data of where the air pollution is around the world. You can see the United States is actually quite clean. In the 1970s, that was not true, of course. And you can see that there's these very high levels of air pollution in India and China, other parts of Asia, sub-Saharan Africa. And then the second part of this is you can convert it into the gain in life expectancy that people would be able to achieve if where they live came into compliance, in this case with WHO standards, or you could set it to any standard. It could be the standard of their own country. All right, so there's a question. Excellent.
How far away do you keep we're safe?
Yeah, so the question is, how good is the satellite data? I think it's like 10 kilometers by 10 kilometers.
Why was the air pollution worse in the 70s?
Oh, in the U.S.?
In the U.S.
Oh, because we didn't, so the question is, why was it so bad, which I didn't show, but why was it so bad in the United States in the 70s? It was before we had the EPA, it was before we had, or when we had just gotten the EPA and we just gotten the Clean Air Act. And there was basically no controls on pollution coming out of stacks. So that was one of the most successful policies the United States ever had. Okay, so, right, so that was the risk of giving this talk at Swarthmore, that there'd be really good questions. And so can you repeat the question? I think you're asking what else is going on in other parts of the figure. And so without getting too wonky, the whole point of the figure and this approach is I don't have a great idea of what's going on here, and I don't have a great idea of what's going on here, but what I have a lot of confidence in is that I understand what's happening right at the river's edge. And I'm asking, is there something discrete happening there? Because there's a discrete policy change. And what this is saying is that there's a discrete jump in life expectancy, which is, there's nothing like that anywhere else in the figure. Okay, all right, one more question, and then I'm gonna keep barreling on.
I noticed like a little bit of like a yellow area along I guess, Southern California. Would that be due to like wildfires, or is that industrial?
Oh, the air pollution in California. Yeah, so this is, you're talking about this, right?
Yes.
Yeah, so that's like the Central Valley. It's got mountains on both sides. And so air pollution can tend to collect there. And it's one of the last parts of the United States that kind of still registers in this data. And so I think a lot of that's transport, and there's a lot of dust, and there's a variety of things there. But that's great, and like USA first and all that, but like on a global scale, it's nothing. Sorry, there's one last question over there.
So your figure, if you go back to I think it's one more. If you go back one more figure, what's going on in British Columbia there because of the proximity to China and airflows? So that's one of the issues, because there are issues with dust.
Excellent. So this is the danger of like putting up data in front of like didn't I start this talk by saying how disappointing data is? I can't tell you every data point on here, so I don't know what's going on in Canada, but I'm going to guess it's like there's a lot of industrial activity there, but I don't really know. Was there an answer? Tar sands. There's definitely tar sands. I don't know. Maybe this is tar sands production. I'm not sure.
Yeah, I would actually look at the airflows, because when there are dust storms in China and pollution coming from North Korea and that industrial part of China, I mean, I think that's probably going to be a significant issue to look at.
It could be. So this is supposed to be filtering out the dust, but I think imperfectly. So, but we're way at the edges of what I should be talking about. But this is like satellite people now. Okay, but so what I wanted you to take away is, wow, there's a lot of air pollution that's really bad for people. In China, the average person, and this is remarkable and really deserves note. In 2013, China declared a war on pollution. And since then, there have been just dramatic reductions in air pollution. And now to the point where the average person in China is losing about 2 years of, or would gain 2 years of life expectancy if China came into compliance with WHO standards. In India, it's much worse. There's this industrial belt, especially in the north, and the average person in India is losing about 5 years of life expectancy relative to achieving WHO standards. And so if you put it all together, and like, this is a little bit of like, I don't think this has penetrated the public consciousness. The average person on the planet is losing more than 2 years of life expectancy due to particulates air pollution. And so That's more than smoking, that's more than alcohol and drug use, it's more than road injuries, HIV, malaria, conflict terrorism, all of it. And so like, just imagine that, like we invited something into the planet, like imagine guys from Mars came and started taking 2 years of life expectancy from everyone, there would be outrage. But this is kind of a quiet killer and is, as the data say, causing people to lose about 2 years of life expectancy on average. In the United States, it's much less. In India, it's much more. Okay, and so I would say particulate matter, air pollution is the single greatest external threat to human health globally, and probably that phrase is missing currently, the word currently. Okay. So the second problem with fossil fuels, I mean, it's great that they can produce energy so inexpensively, but the second problem is that they're leading to climate change, and its impacts or projected impacts are large and heterogeneous, and I'm going to try to come back to that. So here, this is the distribution of average daily temperatures in India. So you'd read this, that the average person in India faces about 60 days a year where the average daily temperature, that's the average of the high and the low, is between 79 and 81. This is like a historical distribution. What is climate change going to do? So why am I showing this with the daily averages? Because for some reason the climate scientists, they insist on using Celsius, which as a proud product of the Chicago Public Schools, I still have a terrible time with Celsius. And B, the annual average is not really interesting in my view. What's interesting, I think, is the number of days here, because that's where the bad stuff happens, at the very high temperatures. That's where people's bodies get under lots of stress. That's where crops fail. All kinds of bad things happen there. And so what I just want you to see is, like, in India, there's going to be this huge piling up of exactly those days. And so the number of days, you know, where it'll be greater than 90, and that's hot when that's the average temperature, you know, will be, if you add these 4 up, I don't know, that's probably like 100 days a year. So that's the physical impact. I'm now just going to steal from a paper of mine that is meant to show, we'll come to in a second, which looks at, well, what are the impacts of hot days on mortality currently? And it's primarily focused on India, but I'm going to begin by showing you in the United States, just to kind of get your feet wet. So the way you would read this figure is that everything is going to be relative to a day that's 70 to 74. That's a very pleasant day. And what happens when temperatures go up? Well, you can see it is true, more people die. We kind of instinctively know that from heat waves and things like that. And the downward thing is just noisiness in the data or data being disappointing. But basically, there is this relationship where hotter days are dangerous or cause more mortality. But now I'm going to play a trick on you. I'm going to keep this blue line, but I'm just going to stretch out the vertical axis. And you'll see why in a second. So there's the same blue line. But now I've stretched it out. And so why did I stretch it out? Well, because I'm going to show you what that response function, this response function, looks like, except I'm going to show you in India, not in the United States. And so here it is in India. This is red. This is modern day India. And what you can see is that when a hot day arrives in India, it's devastating. And the impact of mortality, we can just drop exactly how large it is for today's discussion, but the impact of mortality is about 20 or 25 times larger when a hot day arrives in India. And so now, let's go back to the beginning of the talk. If you're in India and you're on the red line, and you see the United States and they're on the blue line, so you know it's possible not to live on the red line, like, it becomes almost impossible to think about anything but I've got to get off the red line. Like, the red line is like a terrible way to live. It's like sickness and shorter lives and dying of things that are unnecessary to die from, or really dying of poverty, put in a different way. And so now here's where the rub is going to come. Well, that's great. India should get off the red line. What's the best way to get off the red line? It's what? There we go, burn more coal. And so what India is facing is the same energy challenge we're facing, which is we need inexpensive and reliable energy. They need inexpensive and reliable energy. We're kind of done with air pollution. They still got a lot of air pollution. But they're like, no, and they know all these hot days are coming. So what do they want to do? They want to get rid of the horribleness of those hot days. And so the trade-off between using more expensive energy today in the name of preventing climate change in the future looks one way here, because we don't really have people dying on hot days here. And it looks a different way there. And I think in a way that makes it very hard, or just, I'm not going to put judgment on it. The trade-off looks different. It looks extraordinarily different. And that's part of why I think the climate challenge cannot be looked at in isolation. It has to be seen in this larger picture. So what's coming? Here's from some other work of mine. What's coming is, here's projections of the mortality impacts of climate change around the planet. This is just meant to further illustrate how different the world is going to look to different people. At the end of the century, at the end of the century due to climate change, and let's just pick on Oslo. Oslo's an awesome place to pick on. So the blue places are places where are going to have reductions in mortality risk. And why? How could you have a reduction from mortality risk from climate change? That's because they're going to get rid of cold days, which are very bad for mortality. And the red places are places where there's going to be so many more hot days, it's going to dominate the reduction in cold days. So Oslo, it's very cold right now. Getting rid of those cold days is going to be great. They're going to have a very large reduction in mortality rates. And then you take Accra as a counterpoint. They are not well positioned. They're poor and they're already hot, and they're going to have a very large increase in mortality, projected to have a very large increase in mortality rates. So again, let's just come back to the global energy challenge. What is the meaning of that? It means somehow, we already talked about India, somehow Oslo and Accra are going to have to come to an agreement on what's the right amount of mitigation of CO2, or what's the right degree to which we should restrict the continued accumulation of greenhouse gases in the atmosphere. And their starting points, one rich and temperate and one relatively poor and hot, the problem looks so different. And so that's the point I want to make here. And now let me just try and drive this point well beyond where, just to overdo it, but in the name of, I guess in the name of repetition. So here's the United States. This is annual greenhouse gas emissions by region. So this is the United States, this is other developed countries, these are today's developing countries. So currently we account for about 15% of greenhouse gas emissions. The other developed countries in the world are about 30%. 25%, and today's developing countries are about 60%. So if we zoom forward to 2050, our share is projected to go down. We're going to have relatively small population growth relative to the rest of the world. If you go to the end of the century, and so by the end of the century, today's developing countries are projected to account for 73% of annual greenhouse gas emissions. Okay, remember, in the beginning, you thought that was totally fine because they're poor and they need more energy consumption. But the planet only cares about CO2 emissions, could not care less where the CO2 emissions come from. So if we're going to slow or stop or whatever your favorite version of addressing climate change is, the raw and painful arithmetic of it is that these guys here are going to have very, very large reductions in greenhouse gas emissions relative to what's projected. Now, the biting part of that is these are the exact places that need more energy, and these are the exact places that are not in a position to pay more for that energy. And so until that tension is solved, now in principle, like we could ship bags of money to India and China and Bangladesh, hey, buy green energy with this, but we are having enough difficulty raising our own energy costs in the name of climate change. And even on Swarthmore's campus, I think it would be difficult to run for US Senate on a policy of I want to ship tons and tons of money abroad so that to subsidize energy consumption in other countries. So this is the politically challenging part of this. Okay. So the last point, I guess, is derivative or follows from all this. The climate challenge is substantial and the global energy challenge makes it harder. This is just to kind of, where are we? If the Paris Agreement were to be followed, we'd be on something like the blue line. There's some extrapolation here. In a world of no policy, we would be something like on the red line. And if the world were to stick to 2 degrees, some scientists say 1.5 degrees, you'd have to have emissions follow this pattern, which is this very sharp reduction. I always think it's useful to just zoom in on what does that reduction look like. So the black line is what the planet has been doing. And then if we were to stick to 2 degrees, we'd have to be on one of these lines. And it's just like a massive reduction in CO2 that if you were just following the black line, it's almost unimaginable. But that is what it would take to reach, say, the 2-degree goal. Okay, so my kids and probably Nancy Pelosi and probably Chuck Schumer and Joe Biden would probably say, whoa, that was a bummer. There's got to be something not so bummerish that you can talk about. So I'm going to offer 3 solutions, all of which are super easy to describe and maybe harder to do. So the first is I'm going to come back to the little star or caveat I had earlier about that energy markets are pushing us to use fossil fuels. Well, I'm going to argue now that that's a construction of how we've constructed energy markets. And were we to price energy at its full social costs, the playing field would look very different. So you've seen these numbers before. I'm just turning them sideways here. An existing coal plant is about 3 cents. Natural gas plant is about 4 cents. Nuclear plant is about 9 cents. And then here's the renewables with natural gas backup, and here's renewables using batteries as a backup. And the red ones are circled because that's what markets are going to choose, the way we structure markets. But what if we had an alternate reality where instead of getting to dump CO2 into the atmosphere for free, where you can come and essentially pour garbage on your neighbor, what if energy prices reflected the climate damages that are involved in using fossil fuels? How would the world look? So, sorry here. Okay, so I'm going to just jump to this. So there's something called the social cost of carbon. I worked on setting it for the US government when I worked in the Obama administration. If you were to use a value of the social cost of carbon that I think is actually probably too low, but the Biden administration is currently revising the number, but if you were to use $125 per ton, you don't have to know what that means exactly, how would the playing field change? And you'd see we'd have a totally different world. Coal, which looked like the greatest deal in the history of time, 2.9 cents per kilowatt hour, is now like way out of the money. It's like existing coal plant is 18 cents. A coal plant with all kinds of conventional air pollution equipment on it would be like 22 cents a kilowatt hour. The natural gas plant, which was like a far and away winner along with the coal plant, now looks like it's close to the money, but it's no longer such a great winner. Nuclear, which nobody will build in the United States because it's totally non-economic right now looks like a great deal. And then you start to see even renewables with battery backup would be competitive in this landscape. And so we have constructed energy markets in a way where we're like closing one eye to the cost of using these fossil fuels. And the consequences are predictable. We're having air pollution, we're having climate change, but that's just a choice. Like, we don't have to do that. And if we didn't do that, we would end up with a very different energy system. Swarthmore College would probably be happy to sign on to buying its electricity from the grid if it was coming from nuclear plants in that way. Okay. Oh, and then you could, it's even worse if you account for the health effects of local air pollution, but I think I've made the point now. How are we doing on pricing carbon? I would say not so hot. Green is about 16% of carbon emissions around the world are priced. I am arguing that the price should be at least $125 per ton. The average price in the places that actually price it is like $2.50. So we got a long ways, or maybe actually I think the 2.5 is averaged over the whole world. I take it back. So it includes the zeros. So we're not doing so hot at it, but I promise you that I can describe a solution. This is a solution. We would have a very, very different world if we chose to set up our energy markets to reflect the full cost. What are we doing in the United States? United States policy is piecemeal and often expensive. We end up with like small sector by small sector policies. This is the cost per ton of CO2 abated. It's very, very high and variable across the policies. If you use, many of those policies would be difficult to justify if you use the Obama social cost of carbon. What's striking is if we used markets, so like cap and trade markets, like is used in California and like is used on the East Coast, which is called RGGI. I think Pennsylvania is contemplating joining it. You could get reductions in CO2 at much less expensive prices than in the kind of Rube Goldberg approach that characterizes a lot of US climate policy today. The second thing we could do is we could invest in innovation. And so there's like a basic market failure around innovation. And so particularly around the early stages of innovation, the problem is I might have some idea but I can't really, other people might learn about my idea and they might make a competing product, and so I don't get all the benefits of it. And so there's a very strong case for government investing in producing new knowledge and innovation. I'm not going to have time to walk through this. The policy innovation, let's just jump through that. But there's a really strong case for doing technical innovation. And what would that innovation promise us? If we had a lot more innovation in wind, solar, hydrogen, some other or nuclear low carbon energy source, it might be possible for these low carbon sources to actually beat the fossil fuels. And so there's a good case for doing that. And in fact, there has been really tremendous progress in several complementary low carbon technologies. Here's the price of a battery pack in the last 10 years. Here's the price of wind and solar. But all that could be juiced much more and in ways that we can't predict. And I'll just point out, though, there's always going to be innovation, not just in the low carbon ones, but also in the fossil fuels. And so part of the reason it's so important for government to invest in innovation is because like Exxon and Schlumberger and all the other fossil fuel companies, they're not going to sit around and wait. They're constantly coming up with new ideas and driving down the cost of fossil fuels. Here's a picture, which we don't have time to go through, on how hydraulic fracturing works. And there's certainly a lot of that in the other half of Pennsylvania. I don't think we have time for these. Okay. And so then, I guess I will also say there's lots of room for improvement. So I described the solution. How are we doing on it? Well, we spent a lot more on energy R&D during the oil crisis in the 70s. I think there's room for improvement for the world in spending more on energy R&D. So that's a second thing. And then the third question, which is I think a very common question, and is like, well, what am I supposed to do about all this? Like climate change is like big and nasty. And as an individual, like, should I compost more? Should I recycle more? And like the answer, no, you shouldn't do any of those things. I mean, they're fine to do, but they're not making an appreciable dent against climate change. And so I have started a nonprofit that aims to provide a way for people to inexpensively and credibly reduce their carbon footprint. There's other ways to do it. I don't mean to say that this is the only way. And I think what is often a mistake we make is to go for policies or ideas that seem like, that are related to the thing we care about, in this case CO2, but often those things end up being pretty inefficient. And so you should go right for the jugular here. And the jugular is CO2 emissions, and finding some way to reduce your CO2 emissions either through changes in your behavior or finding offsets, which some people don't like, but I think the planet doesn't care where the reduction in CO2 comes from, and I think they're an important part of the arsenal. So I'm gonna not spend a lot of time going through that, and I'm just gonna return to where we began, which is with our guy in Beijing, which my friend Nancy Chen pointed me to this picture. So I think, I tried to be provocative. Climate change, I think it is not effective or maximally effective to think about solving the climate challenge. And rather, I think you have to zoom out to the global energy challenge. And that global energy challenge has really got three features to it. And they are how to have access to inexpensive and reliable energy, how to avoid choking ourselves with nasty local air pollution, and how to avoid disruptive climate change. And finding an answer to that in any one place is in every place is gonna involve trade-offs. And I think what's important to remember, particularly for the climate part, which is really global, is that those trade-offs look so different depending on where you are in the world. And how it looks in Mumbai is not how it looks in Swarthmore, is not how it looks in Tokyo, is not how it looks in Moscow. And the challenge is to find a way people are seeing the world in such different ways for good reasons to navigate those trade-offs and their differences around the planet. So thank you, and I'd be happy to take any questions that people have. There's a question in the back.
Hi, Mr. Greenstone. Thank you for your lecture. I think it's evident from what you say that any meaningful change at this point in time especially requires fundamental shifts in the way we see our economy. And, taking classes here and obviously being in this community, there's a lot of, I think, there's this big elephant in the room that we don't tend to talk about, and that is, while you have these carbon tax policy agenda that we float and we sort of debate in Congress, it obviously goes against all of the interest and the advantages of these corporations that have a lot of power and therefore money and political influences. So with a country like China that has a fundamentally different approach to its market economy, where there's a single power that basically directs everything, versus our more, I think, democratic market economy, do you think that there needs to be a fundamental shift, not in just policies, but the way we conduct our economic system in order to make this, in order to fast track this, and perhaps in a non-ideal way in sort of going towards a more hands-on government mandate?
Okay, I think, it's a little difficult to hear. I think the question, just to repeat it, was on the order of, is it possible to change the, this isn't quite what you asked, but is it possible to change the structure of energy markets in the United States when the current structure benefits some corporations? Is that the essence of the question?
Well, yeah, like you're from the University of Chicago, and with Milton Friedman, there's a lot of freedom for corporations to do whatever they want. And incorporating a carbon tax, obviously, it's not what things like Boeing or ExxonMobil would want. And so they would do everything in their power to stop that, and they're very successful at that. Do you think we need to be more autocratic with the way we mandate these policies?
Yeah, I don't think I don't think I'm quite ready to give up on democracy. And I think actually we should all look within. My own view is it's not always immediate, but we kind of get the government we demand in the end. And one thing, this China example is really important and striking. In 2013, before they declared a war on pollution, I think it was unimaginable to think that Beijing would look wholly different than this within 6 or 7 years. And that happened basically because people were demanding it. And the Communist Party responded to that. And I think, if we look within here, climate change and restructuring energy markets, I don't hear a lot of people, I don't think that's at the top of a lot of top 10 lists of political priorities for people. And I think the political system is, imperfectly, but pretty responsive to what people want. And I think there's not enough, my own view is that there's not enough activism for restructuring electricity markets or restructuring energy markets generally. And as a consequence, we get kind of like incomplete and malformed policy in that direction. So I think it's kind of up to us in the end. Now, does that mean that there are corporations who don't lobby to continue to benefit themselves? Of course they're going to do that. But, I think everyone in this room reads the same polling data I do. There's a growing interest in climate, but it still doesn't rank, it doesn't rank as like a number 1 or number 2 issue.
Thank you. I have the mic here. Thank you so much for your presentation. I think it was extremely insightful. I'd first like to just begin by recognizing that we're on Lenni Lenape land. And then my question for you is, I just came back from a field trip with a course here, and we went down to Chester, and we did like a toxic tour of all the refineries that are there, the incinerator that's there, that's the largest in the country, in a neighborhood that is 70% African American and 70% below the poverty line. And I'm curious for you, as someone who went to Swarthmore, and now you are at the University of Chicago in an area that also has a lot of environmental racism and environmental justice. What do you think is the responsibility of institutions such as Swarthmore, such as UChicago, in these kinds of places in which they have mass accumulations of wealth, of resources? What is their responsibility to engage in the kinds of work that would remediate the situation, either politically or through the sharing of resources?
Yeah. That's a great question, and due to COVID and masking, I am having a little difficulty hearing, but I think the question, let me try and repeat it, is does Swarthmore have, what responsibility does Swarthmore have for environmental risks that are present in Chester? What degree does the University of Chicago have responsibility for environmental risks on the south side of Chicago where I live? Look, Swarthmore is a member of the community it lives in. The University of Chicago is the same thing, and important to stand up for the rights of everyone in those communities. My own view is, we're in an era where we're rethinking the roles of stakeholders in institutions and communities. I think the first, best, most effective is to get government to act. Those are a reflection of government policy, much more than anything else. Should Swarthmore or should the University of Chicago play a role in that? Yeah, I think that's right. But honestly, Swarthmore's job is to educate. I think you said you're a student. Yeah, is to educate undergraduates like myself one day or one long time ago, and you now, and and the University of Chicago's is to do similar things. And I do worry a little bit about mission creep and not becoming and losing excellence at the thing that the institution was built for. And I know different people can see it different ways there, but I think it's ultimately government's responsibility. And do I think Swarthmore University of Chicago should be advocating for a clean, safe environment in their local communities? Of course. But I'm not even sure exactly what Swarthmore University of Chicago could do beyond promoting recognition of these risks. And so some combination of that and not losing focus on what I think is the primary goal of the institution. I think probably, I'm surmising from your question, caused me to be probably a little less forward-leaning than you on that issue. Or you guys are you have the microphones, you're in charge, so.
Sorry for the long box.
Do you think in America without corporatism is possible for the sake of acknowledging the global energy and climate crisis? And you can answer this from any perspective that you choose.
Do I think what is?
An America without corporatism.
Corporatism?
Mm-hmm. And the role that that plays in the climate crisis and the global energy crisis as a whole.
Well, I think corporations are really good at producing products that we like. So I think, I just want to, like, if I'm understanding your question correctly, I want to level the playing field a little bit. Do corporations protect their private interests relative to the public good? I'm sure they do, because they generally are trying to maximize profits, not maximize human well-being. Do corporations also do things that are good for people, like produce inexpensive electricity or inexpensive oil or inexpensive food? Yes, that's also true. And so my own view is I really believe in government's ability to take account of market failures and to take account of people's full interest, not just their desire to have inexpensive energy or something. And I think the responsibility lies at the feet of government for setting the rules of the road. I understand corporatism is like it's probably, there's 100 people in this room, we probably come up with 111 definitions of it. But I think corporations do things that benefit all of us. And I'm sure they also do things that are narrowly in their interest that harm many of us, or that can harm many of us. And I think that's what good policy is for, is setting the rules of the road. So that's my.
I think we're not taking more questions.
Yeah.
Is it what? I'm happy to take one more question, or however you guys want to do it.
Since in the developing world, economic growth means you might go from making $2 a day to $4 a day, and it drives CO2 growth and emissions. And we tend to look at the problem here versus there, and I heard your analysis there, which is good. How do we get economic growth in these areas that need it? Because it's the difference between eating and not eating in many cases. Yet at the same time, take a look and say, well, okay, we have a global problem. CO2 doesn't care where it comes from. So how do you see that, and how does?
Yeah.
How does that?
So. Let me repeat the question just because the math and the COVID is a little bit hard, and make sure I'm not totally bungling the question. I think the question is, what can the United States do, or rich societies do, to facilitate economic growth in developing countries that does not lead to disruptive climate change? Is that? Yeah, that's the essence of it. Okay. I think one thing we could do well, we could ship bags of money over there to subsidize energy. I'm not confident that anyone's ever going to get elected on that one. So I think one thing we could do, and I just want to come back to this because I think it's important. Is this. This is Mike. The cost differential between low carbon energy sources and fossil fuels is an enormous problem. And it makes it look like when you're $2 a day, yeah, give me the fossil fuel. I don't want the more expensive electricity. A massive innovation policy that really tried to soften the bluntness of those cost differentials, or in plain English, made low carbon energy as inexpensive as fossil fuels, would be a gift to the world. We would benefit from it. The world would benefit from it. And then a lot of this global energy challenge will start to melt away. In fact, I think the linchpin of the global energy challenge is exactly that the fossil fuels are less expensive, ignoring what economists call their externalities, the pollution and the CO2, that they're less expensive than the zero carbon energy sources. And so anything we can do to remove that, shrink that delta, is going to facilitate exactly what you're talking about. And honestly, will mean that no one will ever invite me back here to talk about the global energy challenge. It'll be gone. So I think that's the enemy, is those cost differentials. Okay, I think I'm being told we're done, so.